Hi everyone. Thank you for joining us today in our Decision Microservice in Kubernetes webinar. I'm Mélanie Gauthier, modeling at Trisotech, and I'm with my colleague from Automation.
Hello, and my name is Maciej Fidelski. I'm the automation lead at Trisotech.
So today we're going to show you how to take a DMN model created with the decision modeler and use it in a Kubernetes environment. This is one of the ways decision can be deployed in an organization using the Digital Enterprise Suite. So we're going to start by looking at the model, test it in the modeler, and then publish it. We'll then view it in the service library, and then the techie part will start, and Magic will show you step by step how to take it and deploy it to Kubernetes. It will also demonstrate how it can be scaled easily. At the end of the presentation, we will have a Q&A to answer all your questions through the Q&A panel that you can find in Teams. So before digging into the tools, let me give you some context around it. So the decision modeler is a web-based tool allowing to define decision logic. It's based on the DMN standard, Decision and Modeling Notation, created by OMG. DMN provides a simple enough yet powerful way to define decision logic, usually pleasing both business user and technical user. One big advantage of DMN is that it is stateless, making it easy to deploy and scale. So once a model is ready, it can be easily deployed to the digital automation suite with one click, as I will demonstrate. We can also run either the full model or, when we have a more complex one, only a partial part of it based on decision service. So let me show you the example. So today we are going to use the car damage responsibility, which is a simple example from our fictional car renting company. So it has one single decision based on three input data, which are the input required for the service. So the decision inside that is a simple decision table. So each line is a rule, and based on the input, the proper rule will fire, giving us the result. So as I mentioned, I can run it right inside the tool. So let's say I'm a silver member. The damage to the car were the tires, and I'm responsible for the damage. So if I run it, the output of the service is that eRent will be responsible for 20% of the damage, and the renter is going to be responsible for 80%. We can go back to the decision table and see which rule has fired to end up into that result. So you can play a bit with the model, try various combinations to be sure everything works as expected. And then once you're ready, you can publish it to the cloud. You can also include the documentation if you desire so. Let me just publish it. And now it's all done. And I have a link to go view the decision directly. So it's now opening the service library where all the published services are kept. We can have here BPMN model, workflow model, and decision model, which is our focus today. So we have the picture of the model, and I can again try it in the automation environment right here. So again, you see a form really similar to what was in the modeler, and you can run it. So now I know that everything works fine, everything is published. So it's now ready for my colleague that will take it to the next level and show you how to take that and publish it to Kubernetes.
All right, thank you very much, Melanie. So let me now take the screen share. Right. Okay, so starting where Melanie left off, so we have the service deployed, and that is sort of prepared for execution. But this is not the only way you can actually run your service. It's not part of the DS instance that you've been deployed to, but you can even take it further to running in an elastic environment such as Kubernetes. So how it will look like in a Kubernetes environment. So first of all, we have the decision service, which is what Melanie showed us. So we have a running container with the decision service included in the container. It can have one instance or multiple instances, also known as replicas, as we can see here in the screen. And to make sure that it can actually scale up even a single instance, we need to have the container. So this is where we have the container registry that comes into the picture. So we need to grab the image, pull it, and scale up the individual instances or replicas of the service. To make sure that we can easily access those, regardless if there is a single instance or multiple instances of the decision service, we have always the load balancer in front, also known as ingress. So this gives us an excellent opportunity to take advantage of the DMN nature, which is a stateless. So we can run them in how many instances or how many replicas we need. So we can actually accommodate all the load that we have coming from the consumers of the service. So without much of talking, let's jump directly to a demonstration. So let's take the service that Melanie showed us and deploy that into Kubernetes. So we have the decision service deployed in DES, in the automation suite. So we can take now this to our elastic environments such as Kubernetes. In our case, we'll use the Azure Kubernetes service. But what is important here, there are two things in the service library that we can take a look. So first of all is the version. The version is the version of the service, but it is also the version of the container image we are going to deploy to our Kubernetes cluster. This is rather important because we want to make sure that whenever we scale our decision service, we want to run on exact same replica of the service and not having a different types or different versions of the service. So usually when you go to a production environment, you most likely will rely on the actual or concrete version rather than a latest one that might change depending on your development of the decision. So we select the version 1.2 here, and another important part here is that in the advanced option, we have the information about our container image. So the container image details where it can be found, but in our particular scenario, we want to look at deploying to Kubernetes. So we have an options to directly look at the completely prepared for that service, a bare minimal template that will allow us to immediately deploy that to Kubernetes. So if you just grab this file, let me just quickly look at that and present that to you. So if we just look here, this is our deployment template or deployment file already prepared with all the details, as you can see, using the version 1.2. So we have the service, we have the ingress configuration, secret, and deployment. Deployment is fully configured with the liveness and readiness pros. We have the resource limits and request setup. So this is a fully featured deployment descriptor for our Kubernetes environment. So let's grab the content of it and just switch back and jump directly to our environment just to make sure that we don't have any deployments running. And okay, so now what we do is simply create a file that we can just put the, oh, sorry, that was already there. So and do it from scratch. All right, so we have the complete descriptor already in our environment. So we can simply go to our kube control and apply this configuration. All right, we got apply. So let's look at what it resulted. Oh, sorry, the one. All right, so we have the one pod already starting up. It's pulling the container. So as soon as it pulls in and starts the container, we should have that in the ready state. That will make sure that what we get out of the container registry is the complete image. So we don't have to do anything else. It's secured container registry, so we need to make sure that we have all things in place to make sure that it can be successfully pulled in. So now we have the service running. Let's see if it is already exposed to the outside traffic. All right, so we have the host assigned, but we don't have the IP address that is bound to. So let's wait a bit to get the IP address assigned, and now we have it. So we can just grab that and open it in the new tab. All right, so what we have is pretty much what Melanie showed us. So this is the service library of exact same service. So we can take a look at here and look at the trial form. So this is the complete form for invoking this decision. And I will be a little bit better than Melanie. I will go that I'm a membership with gold, not the silver one. So I want to have a better offers. And I have the EU 100. And I hope that's a good thing. 100 is a round number, so it should be good. So that's what we have already deployed in our Kubernetes environment. It just runs there, so we can take a look at the REST API as well, which is as well part of our service. So we can even invoke it from here. And again, as you can see, it's kind of part of it. I'm always gold. So if we run it here, we get the response with exact same reply. We can even get this simple curl command. And if we jump back to our environment, here we go as well. So that shows us very quickly how easy it is to grab the containerized the decision service and run it in Kubernetes in a single instance, but still it's already there. It's running in your elastic and scalable environment. So if we need to, we can scale it very easily, which we'll look at it in a second as well. So looking here back, what we showed right now is that we can build the decision service in a containerized way, a containerized solution, which is called the digital distributed containers in Isotech. But important part here is that what we deliver is already prepared a container image. So it's as part of the cloud publish, the single click deployment option. We already built a container image that is completely self-contained and complete image that can run on its own, so to say. But it can be scaled to as many replicas as you need, again, because of the DMN nature, that is a stateless one. DES comes with the secured container registry, so you don't have to think about, okay, I get the image, but where do I put it? How do I distribute that so my cluster can my Kubernetes cluster can actually access it and pull it? Again, to make sure that this is all protected, we have it secured. So that's why within the Kubernetes template that we use to deploy, we have the secrets as well created that will be used as the image pull secrets for our deployments. Another thing is that what we shown as well is the direct link to Kubernetes. So you can take advantage of the defaults, what we provide you with, but this is completely configurable and you can take full control of what you want to put in your Kubernetes cluster. If you want to have a different type of ingress, if you want to have some additional site containers or sidecars next to your container, for instance, to collect logs and so on and so forth. This is all in your control. And you can do that very quickly in the admin product of the DES. So we have the digital distributed container sections where you have the template configured. So this is the default that we provide you with, and here are a set of variables that you can use within the template that will be filled in whenever you collect or download the template from the service library. This gives you the complete setup and as well the security, where you can create a client application, which will be then used as the secret for the image pull secret. Again, you can do pretty much anything that you need. For instance, you can just modify this one with increased resources if you want to have a slightly more CPU or memory assigned to your containers. All right, so our approach to building the containerized solution is to make sure that this can run in an environments that are extremely elastic when it comes to scalability. So the instances of the service can come and go. So we want to make sure that it is designed from the very beginning to run at scale. So we have the self-contained images, meaning that everything that the container needs to run is within the container. It is secure to make sure that every single time we perform operations, they are protected and they are always available to those that are authorized to do so. And they are versioned to make sure that we can enable the simple scalability and enforcing that different replicas will always run with exact same copy of the service. This comes down to pretty much the immutable or immutability of the images, which is a principle to make sure that we can actually ensure that this runs the way we expect. So regardless of when we scale, how often and to how many replicas, they will always be serving the exact same content of the service. Without any additional accessibility restrictions, so it actually runs without interruptions to the overall service. This is again part of the Kubernetes that ensures that because we define the readiness probes, then the service that is scaling up will only start receiving requests as soon as it's really ready to receive and serve the request, rather than just returning not ready responses like 500 or 503. All right, and this comes down to the next quick demonstration. This is to show the scalability. So let's see, yeah, it's still active. So let's try to scale the service into a slightly higher number. So we just grab a constant request running. So we have here the same, pretty much the same request we did here, but we wanted to run it in the loop. Every second we send a request. On the other side, we want to go to, let me just, yeah, of course, that timed out because it was the first. So let's see. All right, the terminal went down. Just a second. Obviously, it's a demo, so it needs to something needs to crash, but hopefully this is not the decision service, but just the terminal. And we are almost back and running. Requesting Cloud Shell. You see, that's the beauty of running in a cloud environment. So you need to prepare for shutting down some of the terminals from time to time. Almost there, almost there. And let's just do kubectl and get deployment. All right, we have it here. So let's see if this is, no, this is not running, but and we can simply go to kube control and we scale it. And 3 deployment and quickly get the deployment ID. And we scale it. So if we look at now kube control, get bots. And we have already 3 instances. So as you can see, we don't have to spend much of a time on thinking on how this can be scaled. We simply grab them. They will immediately download the images and make sure that they can run with exact same version of the decision service. I can see they already, all 3 are up and running and serving requests. So with this a little bump on the terminal, I think we are good to start with the questions. Thank you.
So we have someone that's wondering, what are the other ways that we could deploy a decision service?
Oh, as you, Melanie, showed that you can run the service actually in the DES automation suite directly. So there is no need for additional environments. So this can be already one of the options. You can run the digital distributed containers, the decision service as container in pretty much any cloud environment. So this is a container image. So depending on how you wanted to deploy it, if you want to have it an orchestrator around it, or you want to simply run it as a single instance, and that's just the few options that we have out of the box.
So I really attentive viewer noticed that you use the Azure Kubernetes services. So would it be much different if we were using Amazon, for example, Amazon services?
Again, I would start with the famous words, it depends, but in general, there won't be that much of a difference, depending if you use a Kubernetes service on Amazon, or you use the virtual machines or any other service of AWS. That might be slightly different, but again, the backbone of the solution is the container image, and the container image is the thing that you deploy. So that should be completely independent of the cloud provider setup you wanted to deploy it to. With some, you will have more options to make it easier. With some, you will need to have some additional work to be done around it.
It looks like it took a while for the initial deployment. Why is that? And would it scale faster than that?
Yeah, it's usually because of the time required to pull the image. So depending on which region you are of your cloud and where is the container registry, in most of the cases, it will be much faster once the image is already pulled to the node that runs your container. So yeah, that will definitely speed up. And if you want to make sure that the execution itself is faster, especially at the startup time, you might look at the resource limits and requests of your Kubernetes deployment to make sure that they have enough CPU and memory, especially at the start, to make sure that they start very quickly.
And in the same spirit, under what kind of load would you typically need to scale the container?
Oh, that's definitely a very valid question. In many cases, it will again depend on your service definition itself, meaning the decisions that are inside the service. But what we found ourselves in the, let's say, the regular environment with a standard set of resources assigned to it, you can expect that the decision service can serve around 10 million requests per day. But again, it will depend very much on the decision you have and the environment you run it on. So best practice is to start simple and fine-tune based on your requirements regarding the load.
And one other question, could this be used to do a kind of blue-green deployment using that deployment method?
Yeah, I definitely think that it could be used in that way. And I guess it's one of the things that you should start promoting whenever you start looking at the deployments into Kubernetes. This could be done in a very different ways. You can use the out-of-the-box things of the Kubernetes environment. So you can, for instance, configure the request balancing on the service itself or on the ingress, depending on the traffic and certain conditions. So you can route the traffic to a version that is the current production and the one that is currently being introduced. So you can then transfer a certain amount of traffic into the new one to make sure that everything's works as expected. There are no errors being returned and so on and so forth. So yes, that's definitely a valid option, yes.
So is there any more question? Don't be shy, you can use the panel and we'll try to answer our best. Okay, so since there seems to be no more question, that will complete our webinar. We are going to send a link to the recording of this presentation to all the registered. And it's going to be available today on the Trizotech website. So thank you, everyone who joined us. Thank you, Magic, for this demonstration. And we hope to see you again very soon.
Thank you very much. See you soon.